Hello, this is Jacob Clark, and this is Vehicle as a Sensor Technique for Soil Property Identification for use in Terra Mechanics applications. This is my project proposal synopsis. And next slide. So background, Terra Mechanical soil properties as they stand are outdated. They are obtained in one study by a guy named Becker in the 1960s using a tool known as a bevimeter. This tool basically presses a plate into the soil to obtain how deep it goes into the soil and the shear properties of the soil. It does not encapsulate true vehicle motion through the soil medium. Not all soil types are fully characterized, and local conditions can heavily affect soil properties. So that means that of the 40 locations that Becker did for his analysis, there's many more locations around the world that soil types are not fully characterized. The next generation NATO reference mobility model uses this data from Becker to determine go, no-go criterion, that is criterion for if a vehicle can or cannot go along the path. Related work is that vehicle as a sensor has been posited but not tested, and therefore not currently the industry standard. Despite how much there is a push for a better system, designs exist for mobile bevimeters, but there's not a system right now that just uses the vehicle as a sensor. The project objective is to validate the vehicle as a sensor approach by instrumenting vehicles of similar configuration but with dissimilar properties and comparing soil characteristics identified from the vehicle as a sensor approach to industry standard approach. Major deliverables of this project include a simple bevimeter constructed and tested. So as a bevimeter is kind of a specialized tool, there aren't really a whole lot available to just buy off eBay. So one will have to likely be constructed and then tested before use. 2 bicycles of different wheel sizes are the primary vehicles to be instrumented and tested, plus 1 other vehicle configuration. So that means a different number of wheels and a different size of wheels to be completed instrumentation and testing. And then plots of the soil characteristics identified from the bevimeter and instrumented vehicle tests. So these are K and N values from Becker's book. Methodology is to first find a suitable test site, so it has to be flat with a well-defined rut depth. To test rut depth and rolling resistance using instrumented vehicles, so this would be to run the vehicle on this surface and to measure the rut depth from the vehicle and the rolling resistance by doing coast down tests. Compare data against the bevimeter, other vehicles in the test to determine the fit. So that would mean that if the 2 bicycles match each other's properties, this is already a relatively successful vehicle as a sensor approach. But if it can even apply for the larger, different configuration vehicle, it would be a bonus. And then determine if the vehicles as a sensor approach is better fit for real-world vehicle applications than the bevimeter. Evaluation metrics include the N and K Terra Mechanical empirical values compared against industry standard bevimeter, and comparing predicted rut depth and rolling resistance values against measured values to determine if the vehicle as a sensor approach applies across vehicles of similar configuration. So basically, if the N and K values identified from one of the bicycles applies for the other bicycle, this further validates the vehicle as a sensor approach. Anticipated challenges include difficulty obtaining accurate rolling resistance and rut depth values, especially out in the field where the ground has a non-homogeneous material. It can be very difficult. Family health concerns, totaled car. I don't currently have a car, so obtaining parts and bicycles and stuff will be difficult. Lead time of the sensors. As far as I'm aware, the sensors should not have a long lead time as they are pretty standard, GPS and ultrasound, but you never know, stuff can happen. Obtaining or constructing simple bevimeter with little documentation. There's not a lot of documentation available of the direct construction of a bevimeter, only what it consists of. Preliminary work includes a theoretical analysis that shows that the soil properties can be obtained basically through 2 different tests. A rut depth test, where you find out the soil work, and the rolling resistance test, which you can find out different properties like the viscosity of the friction of the soil and the N factor here. Resources needed include a bevimeter or materials and design to construct a bevimeter, 2 bicycles, one with different sized wheels than the other, GPS and rut depth sensors to instrument the vehicles, 1 vehicle of different configuration and wheel size than the bicycles, suitable location to conduct the test, and a data logger, likely an Arduino. And the merit impact of this is basically that it's an important application for anything off-road, construction equipment, agriculture, combat vehicles, off-road rovers. Primarily, resources that I've cited in the paper were combat vehicles and off-road rovers, but especially in agriculture, there's a huge application because downtime of equipment means less yield. Up-to-date real-time data gathering is possible if this is successful, and it would replace outdated 60s data gathering.